Hello enthusiasts and welcome. I am happy you made it here today. Each episode, like I always said, we will be exploring specific aspects of physics. Together, we'll dive into key areas and share insights, experiences, and expertise. Whether you are a physics student or simply curious about physics Bible, this session is for you. So sit back, relax, and let's get started on this adventure together. Don't forget to subscribe, like, and share this video for the benefits of other students. Without further ado, let's dive right in. Today, our topic of discussion is change of state. Have you heard of solid, liquid, and gas before? What about freezing and melting, boiling and condensation, evaporation and condensation, sublimation and deposition? What about plasma? If your answer is yes, then you are not far from the truth. Journey with us for an in-depth analytical exegesis by visual method. Understanding the state of change of states, understanding the state of change of matter is crucial in various scientific fields such as chemistry and physics. It helps scientists to predict how substance behave. So, with that being said, what is matter? The beginning, the origin. Matter is anything that has mass and occupies space. This is a combination of the three fundamental quantities. I regard them to be triune fundamental quantities, which is length, mass, and time. Length here denotes space. So matter is anything that has mass and can occupy space. It is a physical substance that makes up the universe and can exist in various states such as solid, liquid, and gas. These are the triune properties. And then there is an inclusion of plasma. Matter is composed of atoms and molecules, which are the building blocks of substance. The state of change of matter refers to the transition that substances undergo from one physical state to another. Matter can exist in 4 different states. This includes solid, liquid, gas, and plasma. When matter changes state, it is due to changes in temperature and pressure. As a substance gains or loses energy, its particles move differently and the arrangement of molecules changes, causing the substance to change from one state to another, meaning heat is very important in change of state. For example, ice, which is solid water, will melt into liquid water when heated to its melting point and then evaporate into water vapor when heated further. So a change of state of matter is the process of turning from solid, liquid, or gas into another one of those states. Solids have their molecules tightly bound. Liquids have their molecules loosely bound and tend to slide over each other. Gases have their molecules not bound at all. So how it all works? The science around us, the theory of everything, the quest to explain all realities. We want to master the change of state using the visual method. So the change of state makes physics very clear. So for a change to occur, heat, energy is required. Therefore, heat is constant. The triune major state of matter, which is equal to anything that has mass, which is equal to weight, which is equal to occupy space. Well, number 1, we have solids. Number 2, we have liquids. Number 3, gases. A dimension of gas is plasma, even though scientists said plasma is the 4th state of matter. All the actions and forces in physics are centered on this trio. In the end, they change their position when forces or pressures are applied, giving rise to motion in solid, liquid, and gases. The triune processes of change of state. Number 1, we have the changes between liquids and solids. Under that, we have freezing. That's number 1. The process of liquid water changing to solid ice is termed as freezing. The temperature at which it occurs is known as the freezing point. Number 2, melting. The process in which a solid changes to a liquid is called melting. The melting point is the temperature at which a solid changes to a liquid. Number 2, changes between liquids and gases. Number 1, we have vaporization. The process in which a liquid boils and changes to a gas is called vaporization. The temperature at which a liquid boils is its boiling point. Number 2, we have condensation. This process is carried out when gas changes to liquid. Number 3, changes between solids and gases. Under that, we have sublimation. The process in which solids directly change to gases is known as sublimation. Then number 4, which is a dimension of gas, we have plasma. It is a 4th state of matter alongside solid, liquid, and gas. It is highly ionized gas. You can underline the word gas, consisting of positively charged ions and free electrons. Plasma is formed when a gas is heated to extremely high temperature or subjected to a strong electromagnetic field, causing the electrons to break free from their atoms, which is why we said that plasma is actually under gases. So plasma is often referred to as the fourth state of matter because it exhibits unique properties that distinguish it from the other states. It is electrically conductive, responds to magnetic field, and can emit light. Examples of plasma include lightning, the flames of fire, and the sun's corona. So in the context of the change of state of matter, plasma represents a transformation from a gaseous state to a highly energized state with distinct characteristics. This transition is driven by increased energy levels, and it is a fundamental part of various natural phenomena and technological applications. So the ground state is equal to the state of equilibrium and is equal to the basic state and is equal to liquid when it comes to change of state. So the triune properties of matters, we have properties of solid. Molecules of a solid are tightly packed and held rigidly together by intermolecular forces of cohesion. Then we have the molecules have fixed positions and they vibrate about these fixed positions. Another one, they have definite shapes and volumes and cannot be poured. The last one, when they are heated, which is the solid now, the molecules gain kinetic energy enough for them to vibrate faster and farther away. Number two, the properties of liquids. Intermolecular forces of attractions are weaker in liquid than in solids, and so they are freer to move about. Liquids have no definite shape, but they have a definite volume. Underline that. They assume the shape of their container and they can be poured. When heated, the molecules gain kinetic energy enough for them to overcome the molecular forces of cohesion so that they can escape from the surface of the liquid in the process of evaporation. Number three, relating to gases now. In gases, the forces of cohesion binding the molecules are negligible. The molecules are therefore very free to move randomly. They are restricted only by the walls of the container. Gases can be easily compressed compared to solids and liquid because their molecules are very far apart. So what are the facts about kinetic theory of matter? We know that matter is made up of molecules. The molecules are in constant motion. In solid, they vibrate about fixed mean position. In liquids and gases, they move in random motion within the fluid. Then we say that molecules of solid are very closely packed. Those of liquids are less closely packed, while those of gases are very loosely packed. So energy is required to break the intermolecular forces of attraction between molecules. What are the real-life applications of change of state of matter in physics? The change of state of matter has numerous real-life applications in physics, some of which include freezing and melting. The change of state between solid and liquid is crucial in everyday applications such as food preservation, freezing, cooking, and making ice cubes. Number two, boiling and condensation. The change of state between liquid and gas is utilized in steam engines, power plants, distillation processes, and the water cycle. Number three, evaporation and condensation. The change of state between liquid and gas is important in processes like drying clothes, humidifiers, and cloud formations. Number four, sublimation and deposition. The change of state between solid and gas is seen in the freeze-drying process for food preservation, the formation of frost, and the sublimation of dry ice. Number five, plasma applications. Plasma, the fourth state of matter, is used in technologies such as plasma TVs, fluorescent lights, and plasma cutting for metal fabrications. So these real-life applications of the change of state of matter demonstrate its importance in various fields of physics and everyday life. Therefore, understanding the state of change of matter is crucial in various scientific fields such as chemistry and physics. It helps scientists predict how substances will behave under different conditions and allows for the development of new technologies and materials. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.